Hello, welcome to this presentation about electrical and computer engineering. My name is Satish Gopalakrishnan and I'm the Associate Head for the undergraduate programs in electrical and computer engineering. I'm going to use this opportunity to tell you a little bit about the undergraduate programs in electrical and computer engineering and potentially the career paths that might lie ahead for students that complete these programs. We'll start by discussing the programs that we do offer and what options are available within these programs. The Department of Electrical and Computer Engineering at UBC offers two undergraduate programs, one in electrical engineering and another in computer engineering. Within electrical engineering, the program includes an option or a subspecialization in biomedical engineering. So the field of electrical engineering is rather broad, and it encompasses a set of technical areas that include computer systems design, digital systems, microelectronics, photonics, materials, control systems, communication systems such as wireless communication, signal processing, so images and audio processing, energy generation, conversion, power distribution, the design of antennas, and robotics in manufacturing. So the electrical engineers create and research, design, develop, and manufacture new devices. The field of computer engineering also covers a wide range of topics, including multimedia systems, robotics, microprocessors, memory systems, computer networks, chip design, supercomputers, and many other aspects of computer organization, including software design and programming. Now, I mentioned that the electrical engineering program has a subspecialization or an option in biomedical engineering. So this option is for students that are interested in applying electrical engineering within medicine and the life sciences. Here, students are exposed to a broad range of specific courses that are related to anatomy, physiology, biomedical instrumentation, medical imaging, and regulatory standards. So there's a wide array of learning that can happen within the electrical and computer engineering programs at UBC. So if you were to come to ECE at UBC, what can you expect to do with your degree? What would your degree look like? I'd like to just highlight a few aspects of the programs. One, you get to work in a rapidly evolving field. Among all the engineering disciplines, I believe that electrical and computer engineering is the fastest evolving. There are changes every day, and the dynamism in this discipline makes it exciting for students and for professionals in this field. If you were to be a student in electrical or computer engineering, one of the exciting aspects are the sophisticated projects that start from very early on in your program. Imagine in your first semester of second year, you will learn how to build a microprocessor, more or less from scratch, and implement this on an FPGA or a field programmable gate array, which is essentially short for a reconfigurable computing platform. So you will learn how to design the circuits, how to think about the instructions that need to be executed on this microprocessor, and actually deploy a significant set of functionality that will actually run on this FPGA board. I think it's remarkable that one can do this in the first semester of second year. You will also be able to work on other projects, often involving aspects of robotics and control systems or wireless communication, as you make progress with the electrical engineering program. And within the computer engineering program, you will learn how to build better computing systems, large software systems like those that power Google or Facebook or Twitter. I'd like to emphasize that our program is flexible and allows students a lot of variety in the electives they choose so that they can pick areas that they are really interested in by the time they reach third and fourth year. We provide the fundamentals that allow for lifelong learning along with this flexibility in elective choices. Another dramatically useful approach in the program is an encouragement to do research. We think that a big part of the university's mission is to generate new knowledge, and we welcome undergraduate students to be part of this journey in joining research labs and working with professors and other graduate students in carrying out cutting-edge research. So what can you expect from your student experience other than the academic work that I've just described? You can engage with the student society. The ECE Student Society is the student organization that manages a lot of the social and co-curricular activities within the program. You can be part of student teams that work on underwater vessels to satellites, to launching satellites, and solar-powered cars if that's what you're interested in. And then you get to build real system capabilities. The Department of Electrical and Computer Engineering is also home to the IEEE student branch. IEEE is the Institute for Electrical and Electronics Engineers, and it's the largest professional body for engineering in the world. The IEEE student branch allows students to connect with the broader professional organization and also organizes networking events and field trips that connect students with experts in the field. As I mentioned, the department does offer research experience, and students that are interested in pursuing more research can complete an undergraduate thesis as they reach third and fourth year. They will also be working on a year-long capstone project in fourth year, where as a team, you actually solve a problem that is related to a client. The client might be a nonprofit organization or a company that's interested in a particular technical problem and is looking for smart and talented engineers to actually solve such problems. So the capstone project provides a perfect launching pad for a career if you're looking to really develop as an engineer. What is the industry demand for ECE students, and what are the career options that you can pursue? I'm going to answer this by providing a few examples of some of our alumni, as well as highlighting some of the companies and organizations that our alumni work at. So here, there are three alum that I'm choosing to highlight. On the left is Eric Lindholm. Eric Lindholm graduated with a Bachelor of Applied Science degree many years ago, and he is now a senior distinguished architect at NVIDIA, working on the technology that powers the graphic processing units that not only help us with our video games or movie watching, but also with our machine learning workload. So Eric was one of the early employees at NVIDIA, and he's been there and is a master inventor for generating numerous patents for NVIDIA. Christina Popp graduated in 2008, and she's an example of one of our alum who went on to pursue research. She got a PhD at Stanford University, and she's since then been a machine learning researcher at Google. Dhruv Rathuri graduated in 2013. He is a senior software engineer at a small startup called Boxbot that does robotics, but he's also worked on firmware systems, and he's worked at companies like GetAround and Tesla. Our alumni do a variety of things. They write patents, they invent new technology, they carry out fundamental research that then leads to new technology, and they have an impact in some of the major companies today, or they're involved with startups. And these startups are at that intersection of electrical and computer engineering, and you get to exercise both your hardware and software design skills. To give you a sense of where many of our alumni have gone, they've gone on to a variety of different places. Naturally, one would think of electrical computer engineers going to companies like Intel, or electrical engineers in British Columbia going to BC Hydro, which manages the power generation and transmission. On the other hand, I want to highlight that some of our alumni have gone on to places like Nike. Why mention Nike? Well, because Nike hires more software engineers than they hire shoe designers, principally because for every shoe that gets designed, there is a lot of simulation in trying to understand the impact of the materials that are used, the dynamics that one can see when that shoe is actually designed before you, or produced before you actually go and manufacture that shoe. So some of our alumni are at places like Nike. Walmart has moved to a lot of logistics automation, and some of our alumni at Walmart as well. And of course, you can find alumni at all of the big companies one can think of, such as Microsoft or Amazon, NVIDIA, Google, and Tesla. They carry out significant engineering work, but they're also involved in roles that one might not have thought of as traditionally engineering related. They are now in marketing, they're in senior leadership, managing large teams, and therefore the opportunities as an electrical and computer engineer are quite phenomenal. I would like to close by saying that electrical and computer engineering degrees allow you to challenge what is possible. You can invent new technologies and innovations in a range of fields, whether that's nanotechnology or biotechnology. Electrical engineers find innovative ways to use electricity, electric materials, and magnetic phenomena like radio waves and signals to make people's lives better. Computer engineers design computer systems, both hardware and software, to create new technology that meets new societal needs. If you have further questions, I encourage you to visit our open house and also find more information at the department's website, which is ece.ubc.ca. Thank you very much. My name is Satish Gopalakrishnan, and I'm the Associate Head for the undergraduate programs in Electrical and Computer Engineering.